Welcome to this explainer. Look, if you're gearing up for the JEE, you already know the binomial theorem can look like an absolute monster, right? Just this massive, intimidating wall of formulas and coefficients. But today, we're taking that daunting theorem and transforming it into a highly tactical, easy-to-use blueprint, one that's designed specifically to help you conquer the exam. We're going to break the whole thing down so it actually makes perfect sense. Rather than just brute forcing your way through endless textbook pages and, hoping for the best, ask yourself this: what could you achieve if you had a single master key? A key to dismantle the absolute hardest exam questions right under the pressure of the clock. Well, that's exactly what we're building today. We aren't just doing math here. We're learning pure exam strategy to turn you into an incredibly efficient problem-solving machine. Okay, let's quickly map out our tactical toolkit. We'll start with the binomial blueprint foundation, then move into patterns, symmetry, and sums, followed by targeted tactical extractions. From there, we hit infinite and multinomial series, dive into advanced applications and calculus, and wrap the whole thing up with the ultimate star master strategy. All right, let's jump right into part one, the binomial blueprint foundation. Think of a standard expansion as a sort of modular drafting panel. You've got your binomial coefficients, your descending powers of A, and your ascending powers of B. But there's a critical hazard right at the center of it all. The sum of the exponents in any given term must always exactly equal n. Literally always. If you ever write down a term and those exponents don't add up perfectly to your original index, you immediately know you've messed up. So, the absolute crucial point here is mastering what's known as the general term, or T sub r plus 1. This isn't just some other formula to cram into your head. No, this acts as your absolute master key. It lets you unlock and extract any specific piece of data from an expansion without having to calculate the entire thing out. It precisely combines a combinatorial weight with your two base elements. It is a total game changer. Let's break that master key down. You can cleanly separate the combinatorial weight, that's the NCR part, from the descending power of the first base element and the ascending power of the second. It's basically a three-part machine. But whatever you do, you must never ever forget the ultimate JEE warning. R starts at 0, not 1. That means your very first term happens when R is 0. Forget that and your entire calculation just totally shatters.
And the way these powers behave across the whole expansion is actually pretty brilliant. See, the descending power of A eventually crosses the ascending power of B. That exact crossing point directly dictates your middle terms. And this split's based entirely on the parity of the index n. Think about it. An even n gives you exactly one perfectly centered middle term. But an odd n, that yields two middle terms sitting right next to each other.
Moving on to part two, patterns, symmetry, and sums.
When we establish a baseline of special expansions by substituting 1 or -1 for x, we reveal this incredible, beautiful symmetry. The total sum of all coefficients is simply 2 to the power of n. But here's the really wild insight. Because alternating signs perfectly cancel each other out, the sum of just the even position terms perfectly equals the sum of the odd position terms, and both of those yield 2 to the power of n minus 1. Honestly, this shortcut is a massive time saver for summation problems.
All right, part three, targeted tactical extractions. Let's start attacking specific exam questions. You know that classic JEE question that asks for the term independent of x, meaning the constant term? Well, when you see this, you need to deploy a strict three-step algorithm. First, write out your general term master key. Second, group all the x variables together so you can isolate their net power. And third, set that net power to exactly 0 and solve for r. It's basically a mathematical magic trick. If x is to the power of 0, x vanishes in a puff of smoke, and boom, you're left with your constant. Let's actually walk through an application of this so you can see it in action. Say we have x plus 1 over x all to the 10th power. Following our steps, we find the net power of x is 10 minus 2r. By setting 10 minus 2r equal to 0, we lock in r as exactly 5. Easy, right? Now just plug that r back into the combinatorial weight, 10 choose 5, and it effortlessly reveals our constant term is 252. No need to expand 11 different terms. Phew, what a relief. Now, finding complex remainders is another huge JEE trap. They love to ask you to divide some massive number by something small and find the remainder. But using a quick four-step sequence reframes the problem entirely into a controlled mission. First, you manipulate the base. Second, you force the divisor to appear. Third, expand to isolate the huge chunk that perfectly divides. And finally, capture the tiny isolated tail at the end as your remainder. Let's look at how this tactic plays out. The mission here is to divide 7 to the 101st power by 25. First, by pulling out 1 7, we get 7 times 49 to the 50th power. Now we just rewrite that 49 as 50 minus 1. And here's the genius part. Because 50 is a multiple of 25, when we expand this, almost every single term contains a 50 and is perfectly divisible by 25. All of that just becomes totally irrelevant. The only thing left, that isolated tail, is the final term. Doing the quick math cleanly exposes our final remainder as exactly 7. On to part 4, infinite and multinomial series. Time to upgrade our arsenal. The crucial point when you're faced with multinomials, like a plus b plus c to the power of n, is bypassing the long, brutal math entirely. The examiners usually just want to know how many total terms there are. So you deploy this sweet combinatorics cheat code. C of n plus k minus 1, choose k minus 1, where k is the number of variables. Honestly, this turns an absolute nightmare of a counting problem into a 5-second calculation. But you have to be incredibly careful here when the index n changes. While positive integer indices work beautifully everywhere and give you a clean, finite number of terms, rational fractions or negative indices, they behave totally differently. They carry a strictly bounded infinite series hazard. You've got to remember, these formulas are strictly valid only when the absolute value of x is less than 1. I promise you the exam will test this exact boundary just to see if you're paying attention. Part 5, Advanced Applications and Calculus. This is for the absolute highest tier problems. It's amazing how calculus transforms these expansions. Taking the derivative of the standard expansion brilliantly pulls down the power, deploying an R multiplier right next to the combination coefficient. Conversely, integrating the standard expansion divides the terms, which creates an R plus 1 denominator. So here's the rule of thumb. If a complex summation puzzle has an R multiplied in, you differentiate. If it has an R in the denominator, you integrate. It's just a gorgeous mathematical trick. You really want to treat these tactics as your ultimate exam day translator. It's all about directly translating the sometimes confusing language of the exam prompt straight into the exact tactical weapon you need to deploy. If they ask for the sum of all coefficients, boom, just substitute your variables with 1. If it's a complex sum involving R, boom, differentiate. It totally removes the guesswork under pressure, so you can just execute. Finally, we arrive at part 6, the Star Master strategy. Let's forge your shield against mistakes. You absolutely must beware of the critical hazards that consistently destroy JEE scores. I'm talking about dropping a negative sign in an alternating series, violating the boundary condition for infinite series, or failing to check if your R is actually an integer. But the biggest one? The absolute trap of forgetting that the R value in your master formula always starts at 0. That means your 5th term actually uses an R of 4. Don't let them catch you on that. To guarantee you avoid those devastating traps, you need to memorize the STAR mnemonic. Use this as your ultimate defensive shield. S stands for the sum of all coefficients equaling 2 to the n. T is for the 2 halves, meaning the even and odd position sums. A is for the alternating sum always equaling 0. And finally, R is for the rth term formula, your fundamental master key. Keep STAR in your head and you're golden. So, I'll leave you with this. When you finally sit down in that quiet room for the real exam, what's it gonna be? Will you rely on rote memorization and risk falling into those carefully laid boundary traps? Or will you deploy this tactical blueprint, use your master keys, and take complete, total control of the test? The choice and the rank is entirely yours. Thanks for joining me for this explainer, and